does anything distinguish the third? And what I'm going to argue is that indeed something does distinguish the third, and it maps exactly onto the kind of Porter-Henderson logic that we've been talking about, and that is about data. If we go back to around 2000, a lot of people were talking about the information revolution, and it was indeed true that the world's stock of data was growing, indeed growing quite fast. But it was still at that point overwhelmingly analog. We go forward to 2007, not only had the world's stock of data exploded, but there'd been this massive substitution of digital for analog. And more important even than that, if you look more carefully at this graph, what you will observe is that about a half of that digital data is information that has an IP address. It's on a server or it's on a PC. But having an IP address means that it can be connected to any other data that has an IP address. It means it becomes possible to put together half of the world's knowledge in order to see patterns, an entirely new thing. If we run the numbers forward to today, it probably looks something like this. We're not really sure. If we run the numbers forward to 2020, we of course have an exact number, courtesy of IDC. It's curious that the future is so much more predictable than the present. And what it implies is a 100-fold multiplication in the stock of information that is connected via an IP address. Now, if the number of connections that we can make is proportional to the number of pairs of data points, a 100-fold multiplication in the quantity of data is a 10,000-fold multiplication in the number of patterns that we can see in that data. This just in the last 10 or 11 years. This, I would submit, is a sea change, a profound change in the economics of the world that we live in. The first human genome, that of James Watson, was mapped as the culmination of the Human Genome Project in the year 2000. And it took about $200 million and about 10 years of work to map just one person's genomic makeup. Since then, the costs of mapping the genome have come down. In fact, they've come down in recent years very dramatically indeed, to the point where the cost is now below $1,000, and it's confidently predicted that by the year 2015 it will be below $100, a 5 or 6 order of magnitude drop in the cost of genomic mapping in just a 15-year period, an extraordinary phenomenon. Now, in the days when mapping a genome cost millions, or even tens of thousands, it was basically a research enterprise. Scientists would gather some representative people, and they would see patterns, and they'd try and make generalizations about human nature and disease from the abstract patterns they find from these particular selected individuals. But when the genome can be mapped for $100, $99 while you wait, then what happens is it becomes retail. It becomes, above all, clinical. You go to the doctor with a cold, and if he or she hasn't done it already, the first thing they do is map your genome. At which point, what they're now doing is not starting from some abstract knowledge of genomic medicine and trying to work out how it applies to you, but they're starting from your particular genome. Now, think of the power of that. Think of where that takes us when we can combine genomic data with clinical data, with data about drug interactions, with the kind of ambient data that devices like our phone and medical sensors will increasingly be collected. Think what happens when we collect all of that data and we can put it together in order to find patterns we wouldn't see before. This, I would suggest, perhaps it will take a while, but this will drive a revolution in medicine. Fabulous. Lots of people talk about this. But there's one thing that doesn't get much attention. How is that model of colossal sharing across all of those kinds of databases compatible with the business models of institutions and organizations and corporations that are involved in this business today? If your business is based on proprietary data, if your competitive advantage is defined by your data, how on earth is that company or is that society, in fact, going to achieve the value that's implicit in the technology? They can't. So essentially what's happening here, and genomics is merely one example of this, is that technology is driving the natural scaling of the activity beyond the institutional boundaries within which we have been used to thinking about it, and in particular beyond the institutional boundaries in terms of which business strategy as a discipline is formulated. The basic story here is that what used to be vertically integrated oligopolistic competition among essentially similar kinds of competitors is evolving by one means or another from a vertical structure to a horizontal one. Why is that happening? It's happening because transaction costs are plummeting and because scale is polarizing. The plummeting of transaction costs weakens the glue that holds value chains together and allows them to separate. The polarization of scale economies towards the very small, small is beautiful, allows for scalable communities to substitute for conventional corporate production. The scaling in the opposite direction towards things like big data drive the structure of business towards the creation of new kinds of institution that can achieve that scale. But either way, a typically vertical structure gets driven to becoming more horizontal. The logic isn't just about big data. If we were to look, for example, at the telecommunications industry, you can tell the same story about fiber optics. If we look at the pharmaceutical industry, or for that matter, university research, you can say exactly the same story about so-called big science. And in the opposite direction, if we look, say, at the energy sector, where all the talk is about how households will be efficient producers of green energy and efficient conservers of energy, that is in fact the reverse phenomenon. That is the fragmentation of scale because the very small can substitute for the traditional corporate scale. Either way, what we are driven to is this horizontalization of the structure of industries. And that implies fundamental changes in how we think about strategy. It means, for example, that we need to think about strategy as a curation of these kinds of horizontal structure, where things like business definition and even industry definition are actually the outcomes of strategy, not something that the strategy presupposes. It means, for example, we need to work out how to accommodate collaboration and competition simultaneously. Think about the genome. We need to accommodate the very large and the very small simultaneously. And we need industry structures that will accommodate very, very different motivations, from the amateur motivations of people in communities to maybe the social motivations of infrastructure built by governments, or for that matter, cooperative institutions built by companies that are otherwise competing, because that is the only way that they can get to scale. These kinds of transformation render the traditional premises of business strategy obsolete. They drive us into a completely new world. They require us, whether we are in the public sector or the private sector, to think very fundamentally differently about the structure of business. And at last, it makes strategy interesting again. Thank you.